Hello. So this is part 2 of the Prim's algorithm, and here we will be discussing with one approach. And let's take a graph structure. Say, for example, this is a 0 which is connecting to 1, and this is connecting to 2, and this 1 and 0 is basically connecting to 3, and this 1 and this 4 2 is connecting to 4, and individually they have their own cost, which is you can termed as weight. So I'm just taking some values over here. Okay, so these are the values or cost which is associated with this one node to another node, and let's try to understand how we can proceed. So there are three types of arrays. The first array is basically the key array. So key array is basically an array we would be which we would say like this is going to be an output. So this algorithm has multiple layers, you can assume it like. So one layer, if it gets executed, then the key array, whatever it contains will be changed, and that change content will be an input to the next layer of this algorithm, and again that next layer will work and will make some changes on this key array, and again that changed or the latest version of the key array is going to be an input to the another layer. In this way you can assume that actually this key array is going to be an internal input of the, you know, what you can say like of the layers. So another thing is like you can assume like whether a node has been visited or not. So based on that, so we are keeping an word array, so it's kind of a visited array, and the last array is basically the parent array. So if we now try to understand that how many size or how many elements may reside into these arrays, whatever we are discussing it right now. So second one is visited array, then the third one is the parent array. So right now I am writing this thing, later on I will represent it key array as k, visited array as v, and parent array as p. So how many elements, what exactly my question was like, how many what is going to be the size of these arrays. So parent, I mean we are having 5 nodes. So first of all this structure, as we have discussed earlier also, like this structure is something which is establishing friendship relationship, because this is a graph. We are trying to convert it into a parent child relationship because we are trying to generate an MST, and which is minimum spanning tree, and tree is always believes in parent child relationship. So philosophically this array mind it is going to be our output. This array will say how this new structure will look like, what would be the parent child relationship in the new structure. So based on that we can draw the MST, so that is going to be our output. After executing every layers, this parent array finally will have its in his own shape, and that shape will actually gives us direction to draw MST in a right manner, right? So let's start. So if we talk about initialization, so the key array initially will be having, as we are having 5 nodes, so it is going to have 5 cells, 1 2 3 4 5. Every value is basically set an infinite. So whenever I'm saying like I'm setting infinite, that means the developers quickly understand this point, that I'm trying to deal with the minimum value, and that's why probably I have set it with a high value, or with a uh, highly big value, so initially no one is parent to no one, so I am putting it -1. So these all are -1s. Visited, initially every cell is not visited, so everything is going to be false, and that's the answer. So there are 5 cells, and these 5 cells have their initial value. So you can see, like you can say, like in the init phase or in the very beginning of the program, everything will look like this. So whenever we are talking now, as I'm mentioning every time, that there will be layers. So how that layer is going to be decided? So the first layer, when it gets executed, it will take an input of the node which is termed as source, because eventually we do not have something called parent or root node which we normally see in the tree data structure, but in the graph data structure we have to mention a source node. Say for example, 0 is basically our source node. So how we stored this graph data structure into computer memory, or memory, that, or how we represent graph data structure, that we know very well, that we can represent it through adjacency matrix or adjacency list. So anyway, any approach, even we can take, and that approach, with the help of that approach, for a particular given node, we can understand who are the adjacents and what is their synaptic weight or what is their cost. Fine. So the first layer, as I mentioned, that will start with node 0, which is going to be our source node. So the first layer is going to input node 0 as their input. So that is our execution of, you can say, layer 1, or you can say like step 1. So in the step 1, what are the things we gonna do? So first of all, we will check that value of this node. The value of this node is basically 0, and that is lesser than the, so if we just index all these items, so we will compare, we will take like the key array, and we will try to compare with the infinity and 0, who is minimum. 0 is minimum, so we are just putting 0 over here in the first cell only, and we will keep the rest of the cells as infinity. So that's the thing, because it's a 0 thing, and this node is visited, as this node is visited. So in the visited array also, we will make a change, we will make it true, and the rest of the items will be false. So I'm not writing it. Now the, whenever we are considering 0th node, so we, from the adjacency matrix or adjacency list, we will try to understand who are their adjacents, and we will iterate through the adjacents. So I'm just writing iterate through adjacents, right? So that is the step. So how many adjacents are there? In case of 0, we have 2 adjacents, so there will be 2 treatments. In the first treatment, we will consider, say for example, node number 1, because this is one of the adjacents of 0. So in case of node number 1, what is the value we can put over there? In case of node number 1, we actually have the synaptic weight is 2, or the cost is basically 2. So 0 to 1, if we consider, we are having a value 2. So we will compare, like in the first position or node number 1, which is the minimum one. The minimum one is infinity. If we compare between infinity and 2, then it is going to be 2. So 0 is the first value which we have already got. So this is like k, this is like k, this is like visited array, so v is like visited array, so k. So in case of in case of node number 1, the cost is going to be 2, and the rest of amount is going to be infinite. I am not writing it. In case of parent array, there should be a change, but this is not something which comes as a primary node. This is the primary node, so that's why in this case, the visited array has been changed entirely, that has been made as true. But whenever we are iterating, the visited array for the adjacent nodes is not going to change. Please mark it. Please make a note of here that whenever we are dealing with adjacent nodes, we don't gonna make any change in the visited array, because that's not the primary array. Because why I'm considering one thing primary, that means I am introducing one concept that is called hierarchy. So I am not in the top hierarchy level, rather I am considering this as a child hierarchy level. So let's, whenever we are introduce that matter, that hierarchical relationship, so that means one array is coming into the picture, and that is like the parent array. So we need to make change in case of parent array. So what that change is going to be? In the first place, that is 0th place, it was -1, but in the second place, if we consider the node number 1, so after 0 it is going to be your node number, it is going to be 1, it is going to be 2, it is going to be 3, it is going to be 4. So you have altogether 5 nodes. So what is going to be the parent in case of node number 1? We are considering node number 1, so the parent of node number 1 is basically 0, so that's why we have put 0, and the rest of the values is going to be -1. I'm not writing it. So do not, so as I mentioned, like do not include it in visited array, because this is not the primary nodes. These are the is as kind of a child nodes which are going to be depicted, but this is something which I have done. Now in case of node 2, so whenever I am considering I have another adjacent. So what is that adjacent is basically that is node 3. Extremely sorry, I said node 2, it should be node 3, because that is the adjacence of 0. So in this case as well, whenever I am considering node 3, so I have to make change what is the value of k array at third position. So we have multiple positions. So 0th position we have 0, 20th position is 2, then infinite, 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 everyone is infinite. Now we are saying that 0 to 6, sorry, 0 to 3 we have a synaptic weight or cost 6. So whenever we are considering we are comparing with 6 and infinite, who is minimum? 6 is minimum. So here we can say like the value is going to be changed 2 3 4. So it is going to be like this, right? And what is the next thing which we need to change? That is, we need to change what is going to be the parent child relationship. So this 3, who is going to be parent of this 3? That is going to be 0. So here if you just see like -1 0, that is 0 1 2 3 and 4. If I just mark this index like this for both these arrays, then in the third position we need to make change, and the third position we need to put 0, because 0 is going to be the parent, and the rest of the values is going to be -1. So that is the step 1. So in case of step 2, if we want to pick step 2, as I mentioned that every layer will take this array, that is like the key array. The latest value of key array is going to be taken as input in every layer. So whenever we are considering step 2, which node we will pick, that is going to be directed by this key array. So how we gonna make that decision? We can make that decision that the node will be, so if I just say the latest value of this key array is like this, so who is actually the smallest, or who is having the smallest value? We can see like 2 is having the smallest value, right? So 2 is having the smallest value. Why 2 is having the smallest value? Because in this case 0 to infinity, 6 and infinity, we have already taken 0. So 2 is something which is left among the rest, right? So how we gonna address this thing? So next node will be actually node number 2. So or we can say like, we can actually, if we can say like this 2 is basically something which is the synaptic weight, but what is the node is basically 1. So we will consider node 1 as the input of step 2. And how we take the decision? We take the decision of latest version of key. So this is like the input of the next layer. Now we will do the same thing. So we will iterate through the adjacent. So what is going to be the adjacent of node number 1? Node number 1, if we just consider, node number 1 has actually 3 adjacents. So but before that we need to make change that this node is a primary node, so we need to make it visited. So let's make it like true, true, and the rest of the things is going to be false, like, right? Okay, so if we just consider or iterate through the adjacents, the same process, iteration, I'm just saying, through adjacents. So the first adjacent of node number 1, okay, so who is basically the adjacents? Just take the list. The adjacent of 1 is 0, the adjacent of 1 is 3, the adjacent of 1 is 4, the adjacent of 1 is 2. So it's a big number. So 0 already we have taken, because we have considered that thing that we can check from the visited array as well. so we won't take 0 already as it's addressed. Now whenever we are connecting 1 2 3, whenever we are connecting 1 2 3, the synaptic weight or the cost is basically 8. As you can see, 1 2 3 is basically 8, right? So 1 2 3 we have 8, correct? But if we just see the key array 0 1 2 3, we have already something called 6, right? So that is not going to change. So that is not going to make any change. So 3 is done, it is not going to make any change of the key array. Now let's consider 4. In case of 1 to 4, 1 to 4, the synaptic weight or cost is basically 5. So now we will come over here into the latest key array, and we will check like what is the synaptic weight of 4. Synaptic weight of 4 is infinite, and here we can see like the cost is basically, or synaptic weight is basically 5. So let's change the key array, and that change is basically happening for node 4. Fine. So in case of node 4, it is going to be 0 to infinite as it was earlier, then 6, and after that the value is basically 5, right? So let's try to see like how the parent array, so this is like key array, so now we will write the parent array. So how the parent array will look like? So if I just say like parent array, at the 0th position it was -1, then 0th position, first position it was 2, -1, and then 0, and in the 4th position, so who is going to be the parent? Parent is basically going to be node 1, so we are just writing node 1, right? So that is like in case of 4 we have done. Now we will consider 2. So in case of 2, if we just consider 1 to 2, what is the synaptic weight? 3. Now in the second position of this key array, what is the synaptic weight? 0 1 to infinite. So we need to change. Yes. So let's write for node 3 it is going to be changed. So the key array is going to be changed over here, 0 2, and in place of infinite it is going to be what? It is going to be 1 to 2 3. So it has to be 3, right? And then 6, then 5. Naturally the parent array, so this is like key array. Now we are going to change the parent array. So who is going to be parent? So we are making change here of node 2. So like -1 0, and then in this case 1, in this case 0, and this case 1. Fantastic. So in case of next step, so the latest version of the key array is basically this. So next step is basically step 3. Step 3, if we just consider step 3, who is going to be the input node? Primary node, if we consider, who is going to be the input node? That is going to be decided through this key array. So after 0 and 2, who is the lesser value? That is 3, right? So 3 is going to be the lesser value. So if we consider 3, that means basically we have to consider node number 2. So if we consider node number 2, who is the adjacent of node number 2? So we have node number 2 this. So adjacent of node number 2 is 1 and 4. Just write 1 and 4. So we need to iterate through 1 and 4. Okay, if we consider 1, so 2 to 1, the synaptic weight is 3, and here the synaptic weight is 0. So it is not going to make any change. Now 4, 2 to 4, the synaptic weight is 7. So here at this particular point the synaptic weight is 5, which is lesser than 7, so it is not going to change. So ultimately this step is not going to make any change on key and parent array. So next if we consider, that is step number 4. In case of step number 4, again the latest version of key array is going to redirect us who's going to be the next one. So 0 2 3, and then 6 and 5. So node number 4 is going to be considered, right? Because the lesser value, if we just consider, that is node number 4, right? So consider node number 4. I'm just writing node number 4. So whenever we are considering node number 4, we need to understand who are the adjacents of node number 4. So if we just see, the node number 4 adjacents are 1 and 2, no one else, 1 and 2. So let's iterate through this list. So first, if we consider 1, the synaptic weight is 5. The synaptic weight is 5. So if we consider this one, the synaptic weight is 2. So it is not going to make any change. Now if we consider 4 to 2, the synaptic weight is 7. If we consider this one, this is 3. So it is not going to make any change. So eventually this is also not going to make any change. Now step number 5. So if we consider step number 5, who is going to be our next node? So we have already taken 0, 2, 3, 5. So left is node number 6, right? So, or we are making any mistakes. 0, 2, 3, 6, 5. So we have taken almost all the nodes, right? Node number 1, node number 0, node number 4, 0, 1, 2 also taken, 2, 0, 1, 2, 4. So actually node number 3 has been left. 0, 1, 2, 3. Yeah, 6. That is node number 3. So node number 3 is left. So who are the adjacents of node number 3? If we just consider node number 3, adjacent is 1 and 0. So just iterate through 1 and 0, right? 0 and 1, no one else. So in case of 0, we have synaptic weight 6, but in case of 0 we have synaptic weight 0. In case of 1 we have synaptic weight 8. Here synaptic weight is 2, so which is lesser than, so no change is going to be made. So finally this is going to be our key and this is going to be our parent. Now if I just write this parent again, the first value is basically -1 because it is basically root. Okay, then this is basically 0, 1, 0 and 1. So if I just want to draw, so we will iterate from this to this, that is going to be fine because 0 is our source, 0 is basically our parent. So who is the, so if I just index it